welcome to our Zoom with the HR MacMillan Space Centre. We have Trish and Rachel here with us, and we're going to be wrapping up some stuff that we've been talking about over the past couple months and talking about what we can see in our night sky over the summer. So I'm looking forward to hearing what you guys had to say today. So Trish and Rachel, you can take it away.
All right, so when you go outside and look up at the nighttime sky, what do you see? Well, most nights you see things like the moon, you'll see the stars, and maybe even some planets. And people just like you and I have been looking up at the night sky for many, many years. And what they've done is they've connected the dots between these distant points of light to make patterns and make things like constellations. And then they might have looked a little bit something like that. Now, many people all over the world have told stories. People like the Greeks and the Romans have told stories of these constellations, these patterns in the nighttime sky, of things like mythological creatures, animals, and even objects. And tonight I'll share with you some of these stories and how to find them on the nighttime sky. Now let's start off with something that you might recognize. So here we have the Big Dipper and the Little Dipper over here. They look like almost like gigantic spoons in our nighttime sky, and you can find them pretty easily. The Big Dipper, the bigger one over here on the left-hand side, looks kind of like an upside-down question mark or a big soup ladle. So it's really easy to find. And once you've found the Big Dipper, you can use the two stars in the cup part of the Big Dipper, and we call those the pointer stars because they point right at the North Star, just like this. And they're pointing at the North Star. That North Star is also called Polaris, and that's because it points us towards the north, and it's in the handle of the Little Dipper. Now, the Big and Little Dipper are part of constellations called Ursa Major and Ursa Minor, meaning the Big and Little Bear. Now, you might have noticed that I also turned on another constellation down here in the bottom, and it looks like a big W or a big M, depending on the time of year. And that's a really cool constellation. It's called Cassiopeia. Now, according to Greek mythology, the story goes that Cassiopeia was a queen. She also had a daughter, a princess, and her name was Andromeda. Let me pull up the Andromeda constellation here as well. So mother, daughter, queen, and princess here in the nighttime sky, but they weren't always in the nighttime sky. They actually used to live on land next to the god of the sea, Poseidon. But Queen Cassiopeia loved to talk about her daughter. She loved to talk about how beautiful she was, and Poseidon just got sick of hearing it. And so Poseidon banished them to the nighttime sky, where they're forced to live out their days up here on our nighttime sky. We can see them all year round. I think that's pretty cool. Now, besides constellations or groups of stars, what are some other things we can see? Well, we can actually see a whole other galaxy. You might think that it's the Milky Way galaxy, the galaxy that we live in, but it's actually a whole separate other galaxy. I like to call it our sister galaxy, and her name is Andromeda. So I'll bring up Princess Andromeda again, and you can see this galaxy. It's going to look like a white smudge just above Andromeda here. Now, it's hard to see on this screen, so let us fly to the Andromeda galaxy and see what it looks like. So if you jump in a spaceship and fly there, this is what the Andromeda galaxy would look like, and it's the furthest thing that we can see in the nighttime sky with just your eye. You don't even need binoculars, don't need telescopes, just your eyeballs alone. You can see this far, far galaxy. And let's go back and take a look at what other things. So I said that we could see constellations, things like all these figures that I've pulled up, but we could also see things like planets. Let me turn on some big planets, make them bigger in our nighttime sky so we can see them a bit better. And I'm also going to speed up time a little bit because these planets are up really, really early in the morning, around 3 to 5 a.m. So if you are an early bird, you can get to see these planets, or if you go to bed really late, you'll be able to see them too. So here we have two planets that you're coming into view right now. Those are Jupiter and Saturn. I'll turn on some labels here so we can see them a little bit better. Now, these two planets are really cool because they are the two largest planets in our solar system. Jupiter is the biggest, Saturn is a little bit smaller, but it's still quite large. And Saturn has those beautiful rings. They almost look like ears on Saturn. It's not the only planet to have rings in our solar system, but I like to think that they are the most beautiful and they are the most spectacular. And if you stayed up a little bit later, you'd be able to see Mars as well. You can see the red planet towards the right side of the screen. And also you'll notice that there's also a blue planet right next to Mars, and that is Neptune. Now, unfortunately, Neptune is way too far for us to see with just your eyes, so you'll need a telescope to be able to see that blue planet. So if you have a telescope at home, or maybe you know a family friend that has a telescope, you can borrow it and try to see that blue marble that's really, 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 really far away. But because I do have the power to travel to these planets, let me show you what they would look like if we could fly there in a spaceship. And I always like to start with Jupiter because it is the biggest and it's got so much going on its surface. And here we are at Jupiter. I'll turn it over to the daytime side. And we've seen it before. It's got a lot of stuff going on. It's got these little bands going across and also huge, massive storms. And what's really cool is if you take binoculars or even a telescope and you take a look at Jupiter, you can see its 4 biggest moons going across its surface. You'll see their shadows and they'll look like almost bright points of light. They'll look like tiny stars, but they're actually the 4 biggest moons of Jupiter. And we call them the Galilean satellites because they were discovered by astronomer Galileo Galilei. And I'll also take us to Saturn because I think that's always a beautiful planet to look at. Here we are. If you had binoculars, you could also see Saturn's rings. Binoculars would help make that golden color of Saturn a little bit more visible, more gold. And you'll be able to see the rings with binoculars. And I think that's always really cool that we can see something so far. And Saturn is actually the last planet that we can see with just your naked eye alone. It's very, very far away, very, very large, very beautiful. And I'll jump this back. And a little bit later on in the year, in August, you'll be able to see a beautiful meteor shower that happens every year. It's called the Perseids. I'll talk a little bit more about that as we get closer to when we have the meteor shower peak. But it's good to get to know your constellations before then because your constellations help you map out your nighttime sky. So when astronomers are talking about the sky is very big. I can say, hey, look in the constellation Cassiopeia. And then immediately you know where Cassiopeia is. It's down at the bottom of the screen, looks like a big W, and then you know what part of the sky to look at. So we'll get more into that when we do talk about the Perseids meteor shower happening in mid-August. But for now, let me just stop sharing my screen and we'll turn it on to a Q&A session.
You brought up some really cool things and a few things that got me thinking. I know you mentioned that telescopes can certainly help us look at the nighttime sky. And I don't know if my friends watching know that the Fraser Valley Library actually loans out telescopes, the same as they loan out books. So if your parents have a library card, they can go online and actually reserve a telescope to look at in your backyard. Now, I think that's pretty cool.
That would be so cool. And you can practice the skills that we talked about today and look for those constellations like the Big Dipper, the Little Dipper, Cassiopeia, and even look at some planets too.
Absolutely. So when I look at the nighttime sky, there are so many stars up there. I like to turn my imagination on and think about those constellations that you're talking about. And I often even play connect the dot in the sky. So maybe some of our friends want to think about that over the summertime. And if you're up late and in a dark spot, even if you're camping or in your own backyard, you can look up at the sky and play connect the dots. And then the next day, write your own constellation story. So come up with your own imagination about what the characters in the sky are doing. One of my favorite ones is the Big Dipper and Mr. Muskwa. Have you heard that one before, Rachel?
No, I haven't.
Oh, Mr. Muskwa is an indigenous story about the Big Dipper or the Big Bear. And it's told about the bear being chased around the sky by 7 birds, and one of them being a robin. So there's certainly lots of really neat stories about the nighttime sky.
So I have a question for you guys. What is your favorite constellation? When you look up at the night sky, is there a constellation that you look at and you're like, oh yeah, I love that one?
And I have an answer that popped into my head right as you asked that, and it's Orion the Hunter. And I love Orion the Hunter because it was in the news a lot last year, and that's because we thought that one of the stars, actually the star that's in the armpit of Orion the Hunter, he's holding a big sword, he's got Orion's belt, and then in the armpit there's a star called Betelgeuse, and that was in the news a lot because we thought that Betelgeuse was going to explode and go supernova, and it was going to be super, super bright. And I love looking at that constellation, especially when I'm walking around at night, because it's just so big on our nighttime sky. It actually always blows me away every time I look at it, exactly how big it is on the nighttime sky. So I love Orion the Hunter, that constellation.
That's a really good one, Rachel. I liked finding Orion as well because oftentimes it's very high in the sky in the winter months. And sometimes when you come outside and it's nice and crystal cold and the sky is very bright, it's very easy for me to spot Orion's belt because sometimes I get confused in the summertime with so many stars. But the Big Dipper, the Big Bear, and how it points to the North Star, that one's my favorite. I love being able to find the North Star by going off the pointer stars of the spoon and then going up, up, up to the next brightest, which is the North Star.
Awesome, thank you. So I think one of my favorites is probably the Big Dipper because it's probably one of the most recognizable from when you're little. But I have a question about the Big Dipper. Sometimes when I look up at the sky, the Big Dipper looks like it's upright, like you can like put soup in it and it's not going to pour out. But other times I look at the Big Dipper and it looks like it's upside down.
That's a great observation, Haley.
Can you explain to me why that happens?
Sure. So here we are. So we see the Big Dipper in the constellation Ursa Major, the Big Bear. I know it doesn't look much like a big bear. Maybe I'll turn on the picture for it. Here we go. And then the little bear over here. So if I speed up time, you'll see that it almost looks like all the constellations are rotating around the North Star Polaris, in the tail of the little bear right over here. And so that's when you see as we're going around in our yearly orbit. Oh, it's getting a little bit brighter. Let me see if I can stop that. Here we go. But you notice that all of the constellations rotated around that North Star point. And so because all the constellations are rotating around the North Star, around the North Pole, we'll see the Big Dipper kind of looking like a big soup ladle at some points, and then also looking like a big question mark as it's upside down, as it turns around and rotates around the year.
Awesome, thank you for that explanation. That makes sense because everything is moving, right? It's not just like a picture or a movie comes up in the night and that's just what it is, but it's actually moving.
Exactly. And some stars or some constellations even dip below the horizon. And so we lose them for some parts of the year. But the ones that I showed you, the Big Dipper, the Little Dipper, and Cassiopeia, are what we call circumpolar constellations. And that really big word just means that we can see them all year round here in the Northern Hemisphere. So that's really cool that no matter what time of year it is, you can always go outside at night and you'll always be able to see those three constellations for sure.
So I have another question for you. About the constellations as well. My best friend and her family, they moved to Nepal. So they're on the other side of the world. And we know for my kids that it's hard for us to talk to them because when it's daytime here, it's nighttime there. So we have like an hour in the morning that we could talk to them or an hour at night. But I'm wondering, because I know it's nighttime there when it's daytime here, when they look up to their sky at nighttime, do they see the same constellations that we do here in Vancouver?
That's a great question. So those three constellations that I showed you, the ones that are up all year round for us here in the Northern Hemisphere, are only up all year round for us in the northern part, or the top part, I'm going to say, of the Earth or of the globe. And so if you lived on the opposite side of the Earth, you're going to see a whole different patch of sky. And so you'll have a bunch of different stars, and you can draw different patterns with those stars, and you'll have different constellations. So people in the Southern Hemisphere will have different constellations that they can see all year round, but because constellations sometimes dip below the horizon, so we tend to share what constellations we see around the year.
I had a friend that moved to Australia, Rachel, and she said that she couldn't see the Big Dipper at all.
Yeah, so that would be because for us, it's a permanent constellation. So we would see it all year round, which means that it's hard for people in the Southern Hemisphere to see what we see up here in the North.
That's very true. She had a really neat constellation called the Southern Cross, which is kind of like our Big Dipper.
So then if, let's say someone is in the Northern Hemisphere, but on the other side of the Earth, like in, what's over there? China or Europe, but still in the Northern Hemisphere, then do they still see the same stars as we do? Or is there a difference there because they're on the other side, but still on the same up?
So they would also see the northern circumpolar constellation, so the Big Dipper, Little Dipper, Cassiopeia. There's actually 9 that we can see all year round, but those are the 3 most popular ones, and I think the 3 that are easiest to find in the nighttime sky. And because our Earth rotates, that's why we get days and nights. Our Earth spins around on its axis, it rotates, and we get different amounts of sunlight based on that. And so because the Earth rotates throughout the night, they'll actually be able to see some constellations as the night goes on, as they rise above the horizon and set once again.
Like I shared last time, we sometimes go up to Green Lake, which is in 70 Mile House in central BC, but it's north of here. And being up there, there's not as many city lights, and so it's easier to see stars and things like that. And we're actually heading up there again on Saturday, and I'm looking forward to seeing what we can see as we get eaten alive by mosquitoes. When we were up there at Christmas time, it was like -15, but we got the kids in their sleeping bags and all bundled up, and we brought them out and laid them on the snow, and we looked up at the sky. And so I'm wondering, when we get there this weekend and lay down and look at the sky, will the sky look different than it did in January when we were there? I think we talked about this a bit.
Yeah, a little bit. So it's kind of the same idea with the Earth's rotation, how we see a little bit different throughout the course of a night, but we also get a bigger effect, or I would say a more subtle effect, but greater over a long time, of Earth going around in its yearly orbit as we travel around the sun, which is why we have, you can look up a table for the different constellations for the different seasons. So depending on where we are in Earth's orbit, we have the circumpolar ones that you see all year round, but then you also have ones pertaining to the different seasons as well.
One of the really neat observations would also be, what time does the sun go down? Because I bet that's very different for you up there in the wintertime versus this time of year, where daylight lasts much longer. I was up in a place called Kitimat last year around this time of year, and somebody actually went outside to mow their lawn at 11:30 at night because it was still daylight out.
Yeah, so that's the tricky thing about stargazing summertime as a kid, because I know my kids go to bed around 7 o'clock, and at 7 o'clock it still looks like it's the middle of the day. So I was just discussing with Lexi that chances are we'll have to put her to bed and then wake her up to see the stars and then head back down, because definitely the sun sets at different times, and like we could go outside like 6:30 in January and see all the stars in the sky. I think the question is, so what time does the moon come up this time of year? Is that the question, Taya? How about we answer that question?
Sure. So we just had our summer solstice, which is the longest day of the year. And I like to think that it's like the midpoint of summer, even though some people say that it's the beginning of summer. But it's really interesting because our sun is up in the sky for so long. And because of that, it actually explains why we have really hot summer days, because the sun spends so much time in the sky, and it heats up our Earth, making it really, really hot. And now because the sun is up for a longer period of time, that means that nighttime is a little bit shorter, and the moon has less time to rise and shine throughout the night. So our sun sets a little bit later. I believe sunset right now is around 9:30 p.m. And then we get the moon rising. And so I'm looking at my moon rise and set chart, and it says that the moon will rise around 11 and 12 p.m. So pretty late.
I have a follow-up question to that. sometimes we wake up in the morning and the sun is up, but the moon is still in the sky. I'm wondering if you can maybe explain why that happens, because sometimes I feel like the moon forgot to go to bed. So how come that happens sometimes, that the sun is up, but you can still see the moon hanging out?
Right, so the sun and the moon actually both, they rise and set at different times throughout the year. And that's why we get things like the longest day of the year and the shortest day of the year. So the summer and winter solstice. Now, it's often confusing why we can see the moon during the daytime, because we think, oh, the moon makes its own light and it should be there in the nighttime only and not the daytime. But what's actually cool is that our moon doesn't make its own light. It actually just reflects a lot of the sunlight coming from, well, our sun. And other planets do this as well. Planets like Venus. Venus has a lot of thick clouds. I think I've shown you guys Venus before, but it has a lot of thick clouds that reflect a lot of light, making it really bright. And the same thing happens with our moon. Our moon has a lot of this white dust on its surface that reflects a ton of light, so that we can still see it even when it's really bright in the day.
Thank you for that explanation. That makes sense, because I agree that some people do think that the moon is shining with its own light, but really it's just the reflection of the sun. And I have so many follow-up questions to that, but we don't have time for that. So Trish and Rachel, thank you so much for the time that you have given us over the past couple months. We've really appreciated it and learned a lot from you, and we look forward to checking in with you again. All right, goodbye. Thank you.
Bye, everyone.